Sharing neutrals on different phases is generally not permitted and can lead to various electrical problems. The National Electrical Code, or NEC, prohibits this practice due to the potential hazards it creates. One of the primary issues with shared neutrals is the risk of tripping circuit breakers. When multiple circuits on different phases share a neutral conductor, the neutral wire can become overloaded. The current flowing through the neutral is the sum of the imbalanced current from each phase. If the combined current exceeds the ampacity of the neutral conductor or the rating of the circuit breaker, the breaker will trip. This is a safety mechanism designed to prevent overheating and potential fire hazards. Secondly, sharing neutrals can cause damage to electrical equipment. The voltage in the neutral wire can fluctuate due to the imbalanced current. This fluctuation can lead to overheating of sensitive electronic components, potentially causing them to fail prematurely. Electronic devices are designed to operate within a specific voltage range, and deviations from this range can damage their internal circuitry. Thirdly, in severe cases, sharing neutrals can even create fire hazards. An overloaded neutral conductor can overheat, causing the insulation to melt or ignite nearby combustible materials. This is especially dangerous in older wiring systems where the insulation may be degraded or brittle. The NEC mandates that each circuit have its own dedicated neutral conductor to mitigate these risks. This ensures that the current on the neutral wire remains within safe limits and prevents voltage fluctuations. While some manufacturers may produce breakers that appear to allow shared neutrals on different phases, it is crucial to understand that this is typically not compliant with the NEC. Always consult the NEC and local electrical codes to ensure that your wiring practices are safe and compliant. If you are unsure about whether your breakers allow shared neutrals, it is always best to consult with a qualified electrician or the breaker manufacturer. They can provide specific guidance based on the breaker model and the relevant electrical codes. The NEC addresses neutral conductors in several sections. Section 300.3 (b) states that all conductors of the same circuit, including the neutral, must be run together in the same raceway, cable, or trench. This requirement helps to ensure that the magnetic fields created by the current-carrying conductors cancel each other out, reducing inductive reactance and voltage drop. Section 310.15 addresses the ampacity of conductors, including neutral conductors. It specifies how to determine the allowable current carrying capacity of a conductor based on its size, insulation type, and ambient temperature. When calculating the neutral conductor size for a multi-wire branch circuit, it is important to consider the maximum unbalanced load. The unbalanced load is the difference between the current on the phase conductors and the current on a neutral conductor. In many cases, the neutral conductor can be sized smaller than the phase conductors, but it must still be large enough to carry the maximum unbalanced load. Section 408.41 covers the identification of neutral conductors. It requires that neutral conductors be identified by a continuous white or grey color. This helps to prevent accidental connections to hot conductors, which can create a shock hazard. Section 210.4 covers multi-wire branch circuits. It defines a multi-wire branch circuit as a circuit consisting of two or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit end which is connected to the neutral or grounded conductor of the system. The NEC provides specific requirements for the installation of multi-wire branch circuits to ensure safety and prevent overloading of the neutral conductor. When troubleshooting electrical problems related to shared neutrals, it is important to use a multimeter to measure the voltage and current on the neutral conductor. A high voltage or current in the neutral conductor indicates that the circuit is overloaded or that there is a problem with the wiring. It is also important to check for loose connections, which can cause voltage drops and overheating. In addition to the NEC requirements, there may be local electrical codes that further restrict the use of shared neutrals. It is important to consult with your local electrical inspector to ensure that your wiring practices comply with all applicable codes. The consequences of violating the NEC and local electrical codes can be severe, including fines, legal action, and potential liability for damages caused by electrical fires or other hazards. Therefore, It is essential to prioritize electrical safety and comply with all applicable codes. In summary, sharing neutrals on different phases is generally prohibited by the NEC and can lead to a variety of electrical problems, including tripped circuit breakers, equipment damage, and fire hazards. Always isolate the neutrals for each circuit and consult with a qualified electrician or the breaker manufacturer if you have any questions or concerns. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. Remember to consult the latest edition of the NEC for the most up-to-date requirements and recommendations. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. Staying informed about these changes is crucial for anyone working with electrical systems. Additionally, consider taking continuing education courses to enhance your knowledge and skills in electrical safety and wiring practices. This will help you to stay up to date on the latest industry best practices and ensure that you are providing safe and reliable electrical services. For example, Section 210.21 B1 states that a 20 amp branch circuit shall be permitted to supply receptacle outlets, lighting outlets, or both. Where the branch circuit supplies more than one receptacle or outlet, the rating of any one cord and plug connected utilization equipment shall not exceed 80% of the branch circuit ampere rating. Section 210.23 A2 allows the total cord and plug connected load not to exceed the branch circuit ampere rating where lighting units, cord and plug connected utilization equipment, or both are supplied. However, Section 210.24 A1 states a 20 amp circuit shall not have a total load exceeding 16 amps where appliances are fastened in place. This is because of the 80% rule, which protects the circuit from overloads. Moreover, there are specific requirements for arc fault circuit interrupters, or ASIs, in the NEC. ASIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires ASIs to be installed in certain locations, such as bedrooms, to protect against arc faults. Sharing neutrals can interfere with the operation of ASIs, potentially rendering them ineffective. This is another reason why it is important to isolate neutrals for each circuit. When working with electrical systems, it is essential to use the proper tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers. It is also important to wear appropriate personal protective equipment, such as safety glasses and gloves. Always to energize the circuit before working on it to prevent electric shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In addition to the safety aspects of shared neutrals, there are also performance considerations. Shared neutrals can cause voltage drops, which can affect the performance of electrical equipment. Voltage drops can cause lights to dim, motors to run slower, and electronic devices to malfunction. Isolating the neutrals for each circuit helps to minimize voltage drops and improve the overall performance of the electrical system. When designing an electrical system, it is important to consider the load requirements of each circuit. This includes the amperage rating of the equipment that will be connected to the circuit and the length of the circuit. The conductor size should be selected based on the load requirements and the length of the circuit to minimize voltage drops. It is also important to consider the future needs of the electrical system. It is often a good idea to install larger conductors than are currently required to accommodate future loads. This can save time and money in the long run by avoiding the need to upgrade the electrical system later. In conclusion, sharing neutrals on different phases is a violation of the NEC and can lead to a variety of electrical problems. Always isolate the neutrals for each circuit and consult with a qualified electrician or the breaker manufacturer if you have any questions or concerns. By following these guidelines, you can help to ensure the safety, reliability, and performance of your electrical system. Always remember to prioritize safety when working with electricity and to comply with all applicable codes and standards. This will help to protect yourself, others, and your property from the hazards of electricity. For example, If a 20 amp circuit has a shared neutral, and one phase is drawing 15 amps while another is drawing 10 amps, the neutral conductor is carrying 5 amps because those are on different phases. Now consider that same setup, but both the 15 amp and 10 amp circuits are on the same phase. The neutral is now carrying 25 amps. This is how overloads can occur and breakers are tripped.